All right, yes. Well, last week we finished up at symmetry, and then we talked about odd and even functions. As a review, how would you determine if a function is odd versus if it's even? Again, you should have done this review at home over the weekend.
You can see if it's odd, if it has negative exponents.
Nope.
F of f of x is equal to f of negative x. That x is negative on the side.
If the function has only odd exponents and no constants. That's one way. That's if you have the function. If you have the graph, if it's odd, what this means is a function like this, which is x cubed. When x is 2, y is 8. When x is negative 2, y is negative 8. So it's symmetric about the origin. That's for an odd function. An even function if the function has only even exponents and possibly a constant. The graph of the function well, this one should be, if I change a sign inside there, it changes the sign of the function. This is an x squared function. If x is 2, y is 4. If x is negative 2, y is also 4. So it's symmetric about the y-axis. All right. So those are symmetries. Now in this section, we're going to talk about something called transformations. Changing the shape and or location of a function. To transform means to change. The types of transformations. Is what our focus is on. The first one is called the horizontal shift. That's where the graph moves left or right on a graph. The vertical shift. That's when a graph goes up or down. Reflection. We have two of those. It could be flipped over the x-axis, or it could be flipped over the y-axis. It's just a mirror image of itself on the other side. It's and or, because if you're doing a shift across the origin, you're actually doing a shift across the x-axis, then doing a shift across the y-axis. Fourth and fifth are going to be the most complex ones of this section. Here we have a horizontal expansion or constriction. That's when a graph can get wider or skinnier. So these two go together and these two go together. It's either going to stretch out or going to be squished in. And lastly, we have the vertical expansion or constriction. That's when a graph can be stretched up or it can be pushed down. To make things easier for you, expansion means to stretch, either out or up or down. Constriction means to squeeze, either to push it together or squash it down on vertically. And that works for both horizontal and vertical. Those same rules apply here as it did in chapter 1 when we talked about circles and graphs of functions. For example, when we talked about a circle, what is that? How would you draw that graph? It's an equation of a circle. What did you need to draw the equation of a circle? You need the center. So what's the center of this equation? 0, 0, very good. And then you need, what's the radius? It's r, whatever that r is. So for example, if we had this equation, center would be 0, 0 because there's no plus or minus hk. And the radius would be what in this case? Let's try again. The radius would, because if it equals r squared, if r squared equals 4, then you have to square root both sides to get the radius. Very good. So the graph would look something like this. The same radius let me put that over here. This new equation. X plus 1 squared, y minus 3 squared equals 4. So where does this graph move? What's my center? No. Yes. How did you find that? Well, yeah, what we did, we took whatever's inside the parentheses because the center, if it's in the center of the whole graph at the origin, then there can't be any x plus, it can't have any x minus h squared, y minus k squared. There's no, so what you do is you took what's inside there and set it equal to 0. That's how you found it. And your shortcut, it's the opposite of whatever, because when you solve it, it's always the opposite. And the radius is 2. So what this thing says is go left 1 and up 3. There's our new center. The radius is still 2. So I go to the right 2, to the left 2, down 2, and up 2. And there's my new graph. The graph is the same size and everything. All I did was shift it from this center to that. I just changed the graph itself, the origin, to a new location. So whatever happens inside the parentheses did what in this shift? Didn't flip anything. There was no flipping here. What does this one do? Which, this one?
We said that. Yeah, that's why I said.
Yeah, but what it originally it was x squared plus y squared equals 4. The graph was here. Now, how did we shift to this new location? So where did this one shift it to? Because both of these contributed. Very good. So this was horizontally left or right. This is vertically up or down. So whatever affects a graph horizontally occurs with the x. Whatever happens vertically affects the y. Well, let me first give you what the general form of an equation is this. That's the general form of equation. Where C is the horizontal shift. D is the vertical shift. If it happens inside, it has to do with the horizontal shifts. So B is the horizontal shrink or stretch. And A is the vertical shrink or stretch. If it happens inside the function, it's horizontal. If it happens outside the function, it's vertical. So looking at this one, you don't need your phone, put it up. You don't need your phone. Because you're always going out in the hallway checking your phone. You don't need that for the 2 hours we're here. So what's going to happen here? What does the original graph look like? So what's the original function here? What function do you think this one is an example of?
A linear function?
Try again. We went over them last week in library of functions. You should have them somewhere in your notes.
See last week.
You were here.
What?
Yes. It's a quadratic function. Very good. The function here is x squared. What does the x squared function look like if you graph it? It's a parabola opening up. Very good. Since this is happening inside there, the horizontal shift looks like this. That's what the horizontal shift looks like. It happens inside the function. So our function is this. So whatever happens inside there is your horizontal shift. So which direction and how many spaces does it move? Nope. 2 is right, but not down. It's horizontal. How can it be down? To the left 2. Because if you took what's inside there and set it equal to 0, then your new origin is x equals -2. So there's your new graph. Again, I said about it 6 times already. If it happens inside the function, it's always the opposite sign. So it's -2. Because it's negative, it shifts to the left. How about that function? So the original function here is 1 over x. That one looks like this. So where's the origin shift? How many spaces?
Right.
Very good. Because it happens inside the parenthesis, inside the function, and it's the opposite number. So what that does, it shifts it to the 3, and there's your new origin. So the graph still looks the same there, but it shifts to the right 3 spaces. Very good. Again, if it happens inside the function, it's horizontal. Here, the change occurs outside the function. Also away from the function. For example, like that example. Here's the function. This happens away from it, outside the function. So it's a vertical shift. It is, the horizontal shift is always opposite since it's inside the parentheses. The vertical shift is what it is. So this graph is the graph of the 1 over x, which looks like that. Now we go down 2 spaces. 1, 2. So there's my new x-axis. So the graph now looks like this.
And the vertical shifts have parentheses or no?
No,
Okay.
nope, because it's outside the function. It's a constant. It's a number. The vertical shift, vertical shift is a constant. I mean, it could, but it's not going to change the function. For example, in this last one we just had, I can have
Still the same thing.
well, no, because now I do negative times negative becomes a what?
Well,
So it becomes a +2. So yeah, we have, if we have a parenthesis in there, we have to get rid of it. It's the constant value. All right, so here's an example. So the original function is not cube. It's the opposite of x cubed. Cube root. Because if it's a small number there inside the v, it's a cube root. So what that graph looks like, it looks like this. That's the cube root function. Now it means just take the whole equation and sink it down one. So there's my new origin. So the same graph looks like this. All I did was shift it down one. All right, so let's look at example one on your worksheet. Graph the following. So the first step, what's the original function? X squared. The x squared, you have to know what your first graph is. That's the first thing you have to look at. What's the original graph? Now, what's the only thing it does? It goes down 6. Very good. 1, 2, 3, 4, 5, 6. So the graph looks the same. It's just been moved down 6 spaces. How about this one? Is it a vertical or horizontal shift? It's horizontal because it's inside there. So the original graph is what? What's the original function? Absolute value of x. What does that graph look like? Very good. It's v. So what does this one do? Go to the right 4 spaces. Very good. So there's my new origin. So I shifted the origin from here to here. So the graph looks the same. Square root of x plus 2. What's the original function? Easiest way to do that is get rid of all the numbers. That tells you the original function. Get rid of all numbers. What's the original function? Square root of x. Right. What does that one look like? Square roots cannot be negative. So it starts at 0 and it grows like this. The faster you memorize the library of functions, the faster this course will go for you. So you don't always have to go back and forth, back and forth, back and forth. So what does this thing do? Nope. Nope. Left 2, but it's inside the function. So we go, if it's inside the function, it's the opposite. So my graph looks like this. All I did is shift the graph 2 spaces to the left. How about that one? Unless it's a fraction, get rid of all the numbers. What's the original function? Yeah, square root of x. So this one looks like that. Is there a horizontal shift? Which direction, how many spaces? Left 2, because it's positive, so let's go to 2, negative 2. There's my new origin, and there's the graph. Then what? Very good. Then you go down 3. So there's my new origin at negative 2, 3. My negative 2, negative 3. And the graph looks the same. Of course, what you have to do is you have to plot some numbers in there to get actual points when you do it for homework. But you know your numbers cannot be less than negative 2. So you put negative 1 inside there. Negative 1 plus 2 is 1. Square root of 1 is 1. 1 minus 3 is 2. Or negative 2. So you have that point. You have that point. When x is 0, it's square root of 2 minus 3. What's that? Well, after we get the idea what the graph looks like, you got to tell me, you got to find me some points. Because you have to plot the points on your computer. So we know the first one, that's the origin. So we know at negative 2, negative 3 is a point of the graph. But because it's square root, it has to be bigger than, because you cannot have negatives inside there. So I try negative 1. I plot negative 1 inside there. Negative 1 plus 2 minus 3. Negative 1 plus 2 is 1. Square root of 1 is 1. 1 minus 3 is negative 2. Then I would go to 4. 2. I'd go to 2 because it'll give me a better number. This is a square root. I need perfect squares. So when x is 2, 2 plus 2 is 4. Square root of 4 is 2. 2 minus 3 is negative 1. So now I have the shape of the curve. You have to do some work in this class.
Don't you look at the graph?
No, because is this graph the same as that graph? Is that graph? No, because they're different shapes. The computer won't take just a rough graph. You have to tell me some points. Because it'll ask you, plot the first one, plot the second one, and go from there. So you have to know more about the graph than just that. All right. So those are horizontal and vertical shifts. The next transformation we talk about are called reflections. Reflections are flips. If that's our first, I don't need parentheses. I need parentheses around that. What does that graph look like?
Origin will be 0 to 0 and go up to.
Okay, you go up two, then what? Up one, it's a linear equation. Go up one to the right one, and there's your graph. What if I change the sign of X? What happens here?
You go down.
We did this in chapter 1. You shouldn't guess. Very good. Because what we did, here's our new origin. We shifted up 2 spaces. Then what we did, we flipped across the x-axis, the new x-axis. So this negative happened outside of X. Let me try this. How about if I gave you this equation? Square root of negative X. It happens inside the function. So it flips across what? It flips horizontally. Anything happens inside the function, flip is horizontal. So what this one does, the original graph is the square root of X. Remember, you cannot have negatives inside the square root. So what does X have to be to cancel that negative?
Zero.
That's only 1 point. Give me the rest of them. A graph has an infinite number of points. You only gave me one. Give me another one. What does X have to be to cancel that negative? Has to be a negative. Negative times negative is a positive. So what we have to do here is now this graph flips across the the y-axis. It's a horizontal flip because it happens inside the function. As opposed to this. It happens outside the function. So what is this graph going to look like? So this one was that. Now this one is that graph. So what's the original graph look like? Square root of X. What does this make me do? Flip vertically across the x-axis. So negative is outside the function. Then flip across the x-axis. If the negative sign is outside, then the reflection, the flip is across the x-axis. If the negative is inside the function, then flip across the y-axis. All right, let's look at example 2. Graph this function. Negative x cubed minus 4 times negative x squared. So what's going to happen to this graph? What kind of function is this? Look at the highest exponent. It's a 3. So what kind of function is it? It's a cubic function. It matches that graph. That graph looks something like this. Which means since it's an odd exponent, both ends go different directions. So that graph would look like, okay, origin there. Looks something like that. Now what have I done? What have I done in this equation? Right. Because I changed x to negative x. So now I'm putting negative values in there. It's still in the origin. Now it's, instead of 4, it's negative 4. What else changes? The direction. How about that one? Whenever you see an equation like this, an example like this, the first thing you have to do is put it in decreasing order. Because this is the larger exponent. So I got to make it like this. So what kind of function is this? It's cubed. So the cube function looks like this. But what happens here is that this graph is with positive x cubed. If I make it negative x cubed, then it goes down. Because the negative is outside. So if I take out two x's, because they both have two x's in common. This one has 3, this one has 2. So I can take out 2 of them. Set this one equal to 0. X equals 4 and x equals 0. Okay. Now let's look at vertical and horizontal stretch and shrinking. So again, if the negative is inside the function, then you flip across the y-axis. If the negative is outside the function, then you flip across the x-axis. Horizontal, shrink, and stretch. Remember we had originally, we had this. Whatever's in front of the function, then you have the function. There's the coefficient of x and then the c, and then your vertical. Now we're going to look at what if inside the function, there's a number in front of x. Inside the function, there's a number in front of x. The graph will shrink if the absolute value of b is greater than 1. In other words, if the number in front of x is greater than 1, that means the graph will shrink horizontally. It'll stretch if the absolute value of b is a fraction. Remember, whatever happens inside the parenthesis is always opposite. If it's x plus 3, we move to the left 3. Same thing here. If we had a function that looked like this, if we had a function that's like this, so if whatever number is in front of x, that's your b. Is it greater than 0 or greater than 1? Yeah. So it means our graph, which used to be this, is now going to be like this. The reason for this if x is 1, then 3x is 3. If x is 2, then it's 6. So it grows a lot faster. And then you square it, which is 936. If we had the function if we had that function. Let's make it a 4 instead, make it easier. So what's going to happen here? Is it a shrink or stretch? What is the b value? 1/4. Because it's whatever's in front of the x. So this b value is between 0 and 1. So what that means it stretches. It goes like this. You ever see those Stretch Armstrong dolls? The dolls you can take them and stretch them. What happens to the image itself? It gets smaller. It gets shorter. So when you stretch something, it gets shorter. So if it happens inside, if it's in front of the x, if it's an integer, what happens? It's a shrink. That means horizontally, it gets closer.
If it's greater than 1.
If it's greater than 1. Even if this one was y equals negative 3x, all that squared. If it's inside, it's a horizontal flip. It's still going to be skinny. If it was 9 inside there, it would be 3 times skinnier. So if it's inside the function, it's always the opposite. If you're multiplying x, that means the graph's going to shrink, or it's going to be compressed. If it's a fraction outside or inside there, that means it's going to get stretched out. Let's see what this happens in a graph. Look at example 2. we have a graph that looks like this. We have at 0, 0. We have at -2, 2. We have a point at -5, 0. So let's look at these points. We have a point at -5, 0, -2, 2, 0, 0, 2, -4, and 4, 0. What would the graph look like if I gave you this? What would the graph look like? So what is this telling me to do? Remember, if it's outside the function, what is it? It's vertical. So 2 times f of x. So my new points we have -5, -2, 0, 2, and 4. So what this thing tells me is all of my y values I multiply by 2. So from 0, it's 0. From 2, it's 4. From 0, it's 0, -8, and 0. So the graph the zeros aren't going to change. They'll never change. Well, unless it's a horizontal shift or a vertical shift. At -2, it used to be 2. Now it's up to 4. It used to be down at -4. Now it's down to -8. So if it's outside, it changes vertically. I multiply all my y values by 2. What's the next one? H of x equals 1/2 f of x. So here, multiply y values by 2. What does this one tell me to do? Yeah, or this one says divide each y value by 2. So 0 divided by 2 is 0. 2 divided by 2 is 1. 0. -4 divided by 2 is -2. 0. So still -5, 0. At -2, it's now 1. At 0, 0. At +2, it's now -2. And at 4, it's 0. So what did it do? It vertically shrunk it. It compressed it. Look at C. R of X is equal to F of 2 of X. D is S of X equals F of 1/2 X. And E is H of X equals F of -1/2 X. These are the ones we have to do next. So C, R of X equals F of 2X. What is that? What's going to happen there? Where is the 2? Inside. So it's what value, what letter in our whole equation? It's the B value. So remember, if the absolute value of B is greater than 1, what happens? Are you sure? Look at your notes. Yeah, because it's opposite. You don't multiply by 2, it shrinks. Horizontally or vertically? Which one? Horizontally. It shrinks horizontally, which means this means we change the X values. This means we change the X values. So remember our original graph was -5, 0, -2, 2, 0, 0, 2, -4, and 4, 0. So what this one does, what this one tells me to do is divide each X value by 2. So we have -5 divided by 2 is, well, -5 divided by 2, -2 divided by 2, 0 divided by 2, 2 divided by 2, and 4 divided by 2. The Y values remain the same. So what happened there? It shrunk. It shrunk horizontally. It got skinnier. So originally it was at -5, -2, originally it was this, Now it's like this. No, like this. 4 divided by 2 is 2, so it shifts from this one to that one. 2 over 2 is 1, so the vertex is at 1. It just squeezes it together. S of x is equal to f of 1/2 x. If b is changed, the new value of x will be found dividing x by b. If you think about it, this is what we're doing. This is for horizontal horizontal. Shrink, stretch. If b is changed, in other words, if your coefficient of x, then the new value of x will be found by dividing x by b. Isn't that what we did here? Here's x, b is 2. So I divided all my x's by b. I do the same thing here. If my x's, what is b here? 1/2. So if I take -5 and divide it by 1/2, I take the top number, leave it alone, multiply it by the flip of the bottom. Then x divided by b would be -5 divided by 1/2 makes it -10. So that's my new x value. -2 divided by 1/2, flip the bottom, so it's -4. 0 divided by 1/2 is still 0. 2 divided by 1/2 is 4. 4 divided by 1/2 is 8. So this one stretches. It went from -5 to -10. Then it went from -2 to -4. Then it went from 2 and 4 to 4 and 8. So if you get a fraction inside there, it stretches it out. And lastly, if I had a -1/2 x inside there, what would happen? Well, you divide by 1/2, but what does the negative do? If it happens inside, it's it reflects across which axis? Very good. So here, divide x by b and flip across the y-axis. All right, so let's look at the original graph looked like this. All right, so that's the original graph. This is f of x. The 1/2 in front of it so here's where I multiply by 1/2. So far, so good, because if it's a fraction, I multiply each value of x. Now, what does this tell me to do? So what this tells me to do, since the negative inside here, I flip across the y-axis. This -10 becomes a +10. This -4,2 becomes a +4,2. This 4, -4 becomes a -4, -4. And then this 8, 0 becomes a -8. So it looks like that. I just took the graph and flipped it. Changed all my x's from positive to negative. The y values stay the same. The only things I changed were the x's. And the vertical just multiply the y values. The sheet I gave you all, the transformation rules summarizes all of this stuff. Vertical shift, if it happens outside, it just goes up 3 spaces. If it's negative, it goes down. Horizontal, if it happens inside, it's the opposite. If it's X plus 3, I go to the left 3 spaces. Reflections, if I change the function from positive to negative, then it flips across the x-axis. It goes up and down. If I just change the x values, I flip across the y-axis. And horizontally, it's just the opposite. If whatever I multiply by x, the new value, I divide each x value by that value. That's a shrink. If it's a fraction, then what I do is I divide the x value by that value. Basically, I multiply by the reciprocal. I'm not gonna lie, it's gonna take some time to practice doing those. And that's why I said you have to practice doing those. All right, that's the end of chapter 2. Now let's start chapter 3. Or any questions, I should say.